Okay, page 2 of the communication notes. Section 2 is a really trivial buffering example, and we're going to use semaphores to communicate between the producer and consumer to synchronize them. And I'm going to call this the handshake protocol, and it comes from serial communication. So we've got one message buffer, and we're going to write a little bit of code here. So we're going to have the buffer size will be a constant, so let's make it a uint32 type and call it buff size, and let's make it half a kb, so 512 bytes. And then we need to allocate storage for the buffer. So since I'm talking in terms of bytes, I'll make it a uint8 type array. I'll just call it buff to save writing, and its size is buff size. So there, we've allocated 512 bytes, and this will be statically. So this will be global declarations here. And I'm going to mix in a bit of pseudocode here. So just because it takes less writing, it's less cluttered. So we're going to have an empty semaphore that will indicate that the buffer is empty. So initially that'll be true or 1. And we'll have a full semaphore to indicate if it's full. And so initially that will be 0. And that's how we're going to synchronize between the producer and the consumer. So here is the producer. Yeah, it can be a task or an ISR. Same with the consumer. And we will do while true. So it's going to produce data, and then it needs to know if the buffer is empty, so it will wait on empty. And the first time it comes to this, it won't have to wait. So it will write to the buffer. Now it could produce and write at the same time. So I'm going to put produce data in brackets here because it could also be happening in parallel with writing to the buffer. And once it's finished producing whatever the data size is, in this case half a kb, it's going to need to tell the consumer that it can go ahead and process it. So it's going to signal full. And that's basically the producer. The consumer will also be an infinite loop. And what it will do is, first thing it needs to do is wait for data. So it's going to wait on full. So initially it will block. Once the producer has put data in the buffer, it will signal the consumer, which will unblock it, and the consumer will read from the buffer, and then it will signal that the buffer is empty. So signal empty. So the producer will have blocked, presumably will have blocked if it's gotten to that point already, and we'll be waiting for that signal so that it can write more data. And then the producer may consume the data, or it might in fact do that in parallel with reading from the buffer. Okay, so we've got this, let's use a different color here. We've got the producer letting the consumer know when it can go ahead, and then the consumer letting the producer know when it can go ahead and write. So this is fairly limiting because the producer and the consumer can't work in parallel. So producer and consumer can't work in parallel. So if we had more buffers, then we could allow them to work in parallel, and probably that would be a better thing.